To the second class of interactive mathematics with Mathematica. So I got it. Okay, good. Right. What I've got here is actually a textbook. I'm writing a textbook for Basai in data analytics, but I'm going to use excerpt from it that basically introduce the basic mechanics of Mathematica and how we can use that to sort of like reorient yourself back to the baseline mathematics, you know, the things that we are going to need for the rest of the program. Okay, so good. Right. So what I would like you to do is all of you, you've got your laptop in front of you, yeah? You have your Mathematica and everything. Okay. So why don't you go ahead and start just a new document. Start a new document. Okay. Oh, what happened? That's fine, that's fine. Use anything. You can use laptop, iPad, just use the launch the program. Yeah. Sorry, I as long as you have to have the what you call it, launch code or access code or license code from IT. Okay. Yes. Actually, I forgot. Yeah. So think about, so this is actually going to be like a textbook, you know, textbook, you open the page, right? Textbook and PowerPoint, it's the same thing. Basically, you just say page 1, go to page 2, go to page 3. I actually, you know, I'm trying to convince the rest of the faculty within Basai not to use PowerPoint for lecture because PowerPoint is very good. I use it all the time because, you know, as a consultancy, I have to sell my idea, right? And when I pitch my idea, PowerPoint is good. Do you know why PowerPoint is good for presentation to pitch idea? Because I'm holding the audience captive, right? I start them on page 1 and I finish on page 10 and I control the narrative. Okay, so PowerPoint is something I use professionally all the time because the story is very good, right? Page 1, oh, there's a big problem. Page 2, there's so many solutions out there, they're no good. Page 3, my solution is best. Page 4, pay me for this project, that sort of thing. Okay, so basically I control the entire narrative. But believe it or not, it's not a good teaching tool. Okay, it certainly isn't interactive. It certainly isn't interactive. You know what's more interactive? Funny enough, chalkboard. When I was your age, faculties did not have the luxury of prepared slides. You know, when I was in college, typically, a lecturer or professor would come in with a book under his arm or her arm. Most of the time, that book is written by him or by her. Okay, fine. Sets it down, and literally, the entire class is taught on a chalkboard. So the lecturer has to write everything from his memory, basically. Okay. Likewise, students have to extract information live. So there's no such thing as a prepared notes. There's no such thing as prepared notes. And that forces students, because that's it. You have to pay attention, you have to focus on the logical construction, because there's no prepared note you can take home. Okay? Nowadays, because you know students have PowerPoint, they get to the habit of just dozing off during class, and then at the end of the class, they just take a PowerPoint home. So I'm kind of like advocate. It's not yet realized, but I'm trying to get the faculties and all the students to wean off this PowerPoint presentation slide. Okay. I still use it again professionally because when I sell the project, I don't want my clients or prospective clients to sort of like veer off into different directions. But anyway, so that's what you should be used to. And in Thai, ขออนุญาตใช้คำว่ามักง่าย it's very easy for say lecturer to talk the slides, and it's also very easy for students to take notes on the slides. But it turns out, in terms of memory retention or learning, nothing beats writing everything yourself. This is really weird. I've learned this. When I learn any subject, I actually take notes, actively take notes. It turns out that the very act of taking notes actively is often enough. Sometimes I don't even have to go back and read my notes. The fact that I'm writing, as I go along, that in itself imprints the logic behind the class and whatnot. Okay, so that's some. Anyway, raise your hand if you've got a problem launching the Mathematica on your thing. Raise your hand if you have problems. So you're okay. So the TA is going to walk around and take attendance, right? Because right now, it's considered attendance. Anybody who's here after this is considered late or missing. Okay. By the way, this is a pre-course, so you're not going to be tested on an A, B, C, D, E. Okay. So as long as you have the attendance and you have the class assignment turned in, it's a pass. Okay. If you fail, it's not a big deal. You take it next year. Okay. But it's not A, B, C, D. Yeah. So don't worry too much about grades. I want you to enjoy. This is, after all, still summer. Okay. Good. Right. So raise your hand again just so I see the sort of number. Who has it? Hi. Don't worry. He does Bill. Okay. 1, 2, 3, 4, 5 about. Okay, but the rest of you have started, right? So that's good. So if you notice, if you start, let's say I do this. Okay, this is a notebook. So I'm going to. Let me start a new notebook. So this is what's going to happen. Okay. You turn on this thing, you start the new notebook. There's a plus sign here. Okay. There's a plus sign here. Okay. That's basically how you enter things. Now, let me give you 5 minutes worth of what's called programming paradigm. Okay. You know what the word paradigm is, right? MATLAB. Okay. Think of your communication. Okay? When your parents want you to do something, okay? How do they communicate that? They just give you, an order or something, right? So let's say they tell you, go get me an umbrella. Go get an umbrella. It's very generic, right? It's very generic. But what it does, your parent is actually calling a function. Yeah, think about it. Again, this is about abstraction. You need to think about this. Go get an umbrella. What is the function? Go get. That go get function is very useful. I can use go get function, go get umbrella, go get my keys, go get this, go get that. Okay, so the this and that is what's called function argument. Okay, it's called function argument. So go get my umbrella. Essentially, it's a function go get with the argument umbrella. That exact same function would also work if I say go get my keys. Okay, now, what if I give you an instruction? Your dad, your mom say, okay? Drive to the supermarket and get me something. Now, this is slightly different because this same command is also a function. However, unlike go get, which is like universal human instruction, driving a car is a skill. So before your parents say drive to the supermarket, your parents have to actually teach you how to drive. right? Right? Same here. This is exactly what we mean by functional programming. Some functions are built in, right? So function like display, show, plot, all kind of stuff, you know, basic. These are built-in functions. But if you want the computer to do something, before you call that function, you have to define the function first. Okay? You have to define the function. Now, Monday, I already mentioned to you that Mathematica is very high level, right? It's very high level. What it means is that such tasks like driving a car, maybe flying an airplane, is so ubiquitous that even though it requires a whole instruction set, it's actually pre-programmed. That's why in Mathematica, you can do things like build a neural network. Okay, so in other words, it's as if the child we're talking to, this program, has been pre-programmed with a whole big, huge library of pre-built or what's called built-in function. Okay, but that's it. Concept of functional programming is that how do you tell computer does thing for you? Okay, that's what you use computer for. So computer is your assistant. You can ask your assistant not with a natural language. You have to give it a function. Okay, so that's the concept of what's called functional programming. Okay, there are other paradigms. I can give it to you. For example, object-oriented paradigm, procedural paradigm, decorative. Now, decorative is a little bit more like Mathematica in that once you get to such a high level, you don't say, go drive to the supermarket and get me a carton of eggs and then make fried eggs. When you say it's decorative, it's a little bit like, I feel like eating omelets. Okay? You go and look at the fridge. If the fridge has eggs, yeah, make an omelet. If the fridge doesn't have eggs, get the key, drive to the supermarket, get eggs, come back, fry, make an omelet. Yeah, that's my wish. My wish is to have an omelet. And I show you a little bit about how high-level Mathematica is by saying, oh, I wish I had a machine that identified image. Okay, so it goes and does this, right? Now, again, the idea is that if you want to be particular, right, you can give additional argument. I want omelet with chives, with sausage, pepperoni, I don't know, onion, shallots. You can do that. But if you didn't, you can just say, I feel like an omelet this morning. And the computer will then sort out this. Okay. In the future, and this is where we come in. In the future, you might have another layer of interface, another layer of language interface. ไม่มาสายหรอกไม่มีนาฬิกาครับแต่ไม่มีมาขอได้นะกูมีนาฬิกาเยอะ Okay, you might have another interface. Okay, and that's large language programming. But you know, until then, you still need to do this kind of thing yourself. Okay. So Mathematica is a functional, primarily a functional programming paradigm. In that sense, it's very similar to Python. Python is also like this. In other words, Python is primarily a functional programming language, but you can implement object-oriented paradigm, you can implement procedural. These are sort of like fine details. But think of it this way, okay? Think of function as your language, okay? Language, okay? So when I say something, good morning, how are you? The function is greeting. That's my function. Doesn't expect anything back. Or if I expect something back, say, good morning, how are you today? Okay, then that means it's an instruction, right? I declare good morning to you and I want you to tell me how you're doing, right? So everything is communication by function. Okay, so if everything is defined by function, what do you apply the function to? Variable, right? So think of y is equal to f of x. That is your language. That's how you're going to speak to the computer for the rest of your career, let's say. Okay? If the computer is dumb, that f of x is so basic. In order to get an omelet, you have to say, there's an F1, get an egg. The result of F1 is crab egg. Call a function to stir. The result of that function is stirred egg. Call another function called heat up the pan, that sort of thing, right? But higher level language, make an omelet. Okay? But at the end of the day, it's function with argument with output. Argument and input, sometimes I use the word interchangeably. Variable, input. Variables is both input and output, right? So y is equal to f of x. Both y and x are variable. In this row, x is the input variable, the argument of the function. Y is the output variable. It is the value of the function. But I can put y into another function g. G of y gives you a q, right? And some function takes more than one input. Okay? For example, omelet with cheese and chives and whatnot. Okay. So let's understand that. Okay. Now this is regardless of what track you are in Basai, you have to say that this is the way modern your generation forward think of communication with a computer, right? It's kind of like instructional, but not detailed. Okay, when I was your age, computer programming was a little bit more detailed. There's like for loop, if, then, and, or. It's very detailed. Your generation is more like this. Function. And the smarter the program is, the more built-in function it has. Now, Mathematica comes with all the functions. All the built-in function, it's got gazillion functions. You'll never be able to exhaust them all. But because it's not written for you, right? It's not written for you. It can do all kinds of things, but maybe not in the combination or the sequence you want. Okay? And let me just give you a dumb example. For some reason, this is how I like to eat my scrambled egg. I like to fry my eggs first, so it becomes like over easy, and then mix them in my plate. So I don't want mix and then fry. I want fry, then mix. This is kind of weird. Nobody does it, so a standard chef doesn't know how to make this. But standard chef know how to fry, so I can make this custom function. So the idea of writing your function in Mathematica is not because it cannot do it, but it doesn't do it in the way you want for your particular need. Okay? The whole concept of computer programming is not to tell it how to do things, it's to tell it what sort of things you want done and orchestrate. You know what orchestrate means, right? You like orchestra conductor. I want to prepare this, this, and this. Once this is ready, I put all this into this, I set it aside, I do something else. It's a bit like cooking. And if I have a long recipe that has sequence of function and this orchestration, what do I have? What do I have? A cooking recipe. In computer term, that's what an algorithm is. Okay? Algorithm is like a set of instruction with internal flow and logic. Okay? So again, mixing and frying. If you mix and fry, that's one algorithm. If you fry then mix, that's another algorithm, even though exactly same component. Same component. Your job, as Basai student, right? It's about integrated innovation. The innovation, chances are, will be expressed. And this is not all case. Chances are, will be expressed or at least demonstrated as an algorithm. Okay, as an algorithm. So if your solution is to solve healthcare problem, by having a logistic for delivering drafts and keeping inventory and do this? Are you going to actually build go to Samyan and rent an office and then have a little mannequin? No, that's too expensive. That's too expensive. You do it here. Okay, so the computer then would simulate your product or your solution.
What is the synonym between the recipe and algorithm?
Same thing. Almost exactly the same thing. Almost exactly the same thing. If you think about it, recipe, and this is very good analogy, okay? Think about it. There's like a generic recipe. There's also special recipe. A special chef can do exact same noodles, but he has got his own secret sauce, right? So why do we go to this shop? Not because there's only one place you can eat noodles in Thailand, but this noodle is so good because the recipe is superior. That's what you're supposed to do. You are supposed to invent superior algorithm. Okay, sometimes it's superior in a tangible, concrete measurement, like my algorithm for shipping products from warehouse to customer in the quickest time over Bangkok traffic. You can measure that quantitatively, faster, 17% compared to average of competitors. Sometimes it's superior because it's more customized, right? So some restaurant would say, how would you like your noodles? There's like, even noodles, so how sticky or how hard, how, some people like very soft noodles and so forth. Spaghetti likewise, right? Okay, so you know how to make spaghetti, right? Well, most people, Italian, they like to say it's a little bit al dente. That means to the teeth. That means like, that's a little bit like, it's not quite cooked. It's cooked, but it's not quite cooked. You throw it to the wall, it sticks. But when you bite on it, there's a little bit. Some people like it, some people don't like it. Now, imagine that you go to a restaurant that says, I'm just going to make spaghetti one way. And the other one said, hey, how would you like your spaghetti? Al dente or mushy? Okay? That restaurant will be more expensive. Right? Likewise, your product, if it's more customizable, will be better, superior. Okay, so that's enough preamble on why it is functional programming is kind of like your vocabulary, your language for communicating. Okay, so let's go. Now, I'm going to start. I have to say, by the way, that today is supposed to be the most boring day because I'm going to teach you the mechanics of how to enter command. Okay, but boring is good. Sometimes boring is good. Okay, so right. So if you start, okay, for those of you who came late a little bit, it's okay. But next time don't come late, okay? When you start, you see this little plus thing, right? Now, if I click on the plus, you will notice that there are actually 1, 2, 3, 4, 5, 6 different things you can do. Okay, 16 different things you can do. Now, actually, the top line is by default. See that? So that if you don't click the plus and you enter something here, it's going to go to that mode. So think of it, there's 6 modes. 6 modes. Okay. Now, the first mode is the first one that you're going to start with. Okay. Basically, can you guys see that there's a line separate between the first one and the 3 one and so forth, right? Okay. So this is basically the core language. This first one. Okay. So you don't have to do this. You don't have to click plus. You just go and type something, right? Now, let me play with something. Let me show you this. Okay, I prepared this to make it silly, but makes a point. By the way, I want you to experiment on your thing, and that's what you turn in at the end of the class. It's an evidence that you are engaged. That's it. That's it. So you come here on time, you do that and then pass. Okay. So what do? You type in A plus B. Well, actually, better, yeah, type in 1 plus 1. Okay? 1 plus 1. Oops. Okay? Now, if you enter, it's just going to go to the next line. Okay? The only thing you have to memorize is that with Mathematica, you have to shift enter to say, over to you. Okay? So this would be like, okay? So that gives you what? 2. Okay? Wow, that's very advanced mathematics there. Okay? You notice one thing. This thing now originally had no number. Now it has a line number. That line is sort of like associated with that action. It's just a record of that action. Okay? In a typical session, maybe you go up to 100, doesn't matter. But the output 1 corresponds to the input 1. Sometimes you have picture in between, so there's a direct reference. You don't get lost as to what's happening to what. Now look to the right side. There's this thing called kernel. Kernel, you know what kernel means in English? Kernel means seed, right? So this is like a little seed. So the seed, this is input. You just say 1 plus 1 and you get 2. And notice there's a bracket that say, okay, together, right? This is so useful in functional programming that when people started using what's a Python language in the 80s, I think, 70s, 80s, somebody who knows Wolfram Mathematica and plays with Python, the development environment there is not very friendly at all. So they copy this style of, bracket, 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 and create this thing called Jupyter Notebook. Okay, so Jupyter Notebook in Python works exactly like this because it's copied from Mathematica, right? So that's why if you are familiar with Python, not other development environment, but sort of using Jupyter Notebook style of programming, you would see exactly the same thing here. Okay, because it was inspired by basically this. Okay, so notice something. Well, it's a little bit hard to see, but 1 is kind of thick. 1 is kind of thick, but 2 is not thick. That's okay. The point is, it's all black, right? Now, when something is black on the screen, okay, first of all, it means it's something that the computer understands. So the computer understands 1. Okay? It knows what it is. It's well defined. Now, what if I did the same thing and I do this? A plus B. You notice, even the color is different. It highlights, this is something I have no idea what it is, A plus B, because I haven't defined what A is. Okay, but let's say I did this first. I say A is equal to 7. Okay, notice. Okay, A is equal to 7, shift enter, over to you. So now 7, it just tells you back, F7. It's that simple. But notice that A is now black. Because now the computer knows what A is. Okay? And if I say A plus B, only B is blue because the thing doesn't know what it is. So shift enter, it gives you 7 plus B. Okay? Because that's all it knows. Okay? And this is very good. By the way, this is also something that in communication theory, I don't know, you might have friends who go to communication department. That's one of the things that they teach probably on day 1. You have to define the common ground between what you know and what the person you're speaking to knows. Okay, in my mind, I happen to think that B is equal to 5, but unless I say so, nobody knows. It's in my mind, right? It's the same thing here. Okay, so being in black means it's understood. You and me understand. Now, exactly how does this look like a function? It doesn't look like a function. It looks like a calculator. Well, and you have to bear with me. This is so simple mathematics, but I'm going to just sort of like make it so difficult. Okay, I'm just going to make it so difficult to add A and B. In Thai, it's called "ขีช้างจับตะกะแตน." That means sort of like you you ride a dragon or something to slay a horse or something. It's that simple. The point is that the mechanics of riding an elephant or riding the dragon is something you can learn. So you can't, I can't teach you to ride a dragon and then slay another dragon at the same time, right? I can teach you how to slay a dog, but that's not useful. So what I'm going to do is I'm going to teach you how to ride a dragon to slay a little pup. That's an easy job, okay? But the tool is overkill. That's what I'm doing, overkill. Okay, let's overkill this thing a little bit more. How would I make this into a function? Well, think, okay, think. You don't have a keyboard, but let's say the computer listens to you. What would you say? You say A plus B, right? But that's not a function, right? A function would be something like, give me the result of A plus B, right? So give me the stuff. So add this thing for me, add for me. So the function is add. How many arguments does add take? 2, right? 2. So, right, just now I said, go fetch me car keys. That's one argument, okay? If I say add 1, does that make any sense? No, doesn't make sense, right? So, except because I write in mathematical symbol, it doesn't look like a function, right? It is a function. So don't think of this as an addition sign. Forget it. This is not addition sign. This is a shorthand for this function. Plus A, okay, 1, 2, and 3, 4. See that? Okay? So this is the overkill I'm trying to get you to wrap your head around. You tell the computer functionally, that's called functional programming. The function is plus. The argument is 1, 2, and 3, 4. This is the fundamental syntax. 12 plus 3, 4, oops, sorry. 12 plus 3, 4 is not the fundamental functional programming. It's actually a shorthand. Okay, so turn your mind around. You learned this in, I don't know, 1st grade or something like that, right? I want you to think the other way around. Computer doesn't do that. Computer says, I'm willing to do new things that you ask me to do. What do you ask me to do? Plus. Once I put the word plus, I'm expecting that you supply me with 2 pieces of information. If I did this, it's going to get confused. Plus 7. Well, in this case, it does because it gives you a default, but some other function, when it's actually expecting 2, if you give it 1, it will complain. Okay? But this one, it doesn't complain because it's, I don't know, it's trivial. Okay? Right. So that's the deal. Okay, so maybe that's a good example. It's trivial. Okay, so you guys on board with me now, on the same page, right? Functional programming, you have to invoke function, and well, the result here, once you get the result, it disappears. The result's in the air. You have to store it somewhere. And this is where you have to make the assignment. So something like sum is equal to, oops, sum is equal to, notice, sum is blue, right? Now I shift enter, sum is equal to 46. So next time I write the word sum, it's going to look black. Shift enter, 46. Well, it's it. Okay? Now, let me do this. Okay, so you can do this and turn this in. Don't worry that it's going to look too long. The TA is going to grade you on your engagement, not on your correctness or whatever. Right. So let me give you this function just for you to be using, because when you're playing with a lot, you start creating so many variables. So how to get rid of it? Like A, for example, now A was 7, right? I want to clear A again, so I just do clear A. Okay, clear A. So now A is going to be blue. Okay, clear? Sum. Okay, sums will be blue. So now there's nothing predefined. Okay, so this is very simple. This is very simple. Okay. Now, so basically, this is what you do. Y is equal to f of x. Okay. Now, I forgot to tell you, but you notice by now that mathematical function is a round bracket. In Mathematica, you use square bracket. That's all. Okay, that's all you have to do. Now, so let's go to that. So this is a plus b. It's this. Okay. This is another way of doing. I'll tell you right now, but don't pay attention too much. But you can see that there's so many ways of adding. There's two numbers. There's a lot of overkill ahead of you. Okay, there's a lot of overkill ahead of you. For example, this is another way of overkill. Yeah, this is another way of overkill. This is another way of overkill. Okay, all of this construct I will teach you, and they'll be useful. They'll be useful. Okay, but right now let's kind of like stick with the program. So I'm going to go to this page. Okay, so this is it's kind of linear because again a textbook is organized like a PowerPoint, so it's pages. I'm gonna skip to page yeah, let's go to introduction to language. Okay, right. Now, this thing, tell you what, we have a line group, right? A line group, do we? You have a line group? Okay, and you guys are summer, right? Summer something. Okay. Okay, that's your line group, right? Okay. So anytime I want to give you sort of like a note you can take, I'll just do this. So variable and function, actually there's a language reference on top. If you actually just go here to reference language to the, there it is, there. Now, you don't have to go all the way here, just go here. Reference.wolfram.com. Basically, everything will be in here, but I want to tell you it's very big. It's huge. It's what's called an ecosystem. So it's not just one programming language, and whole ecosystem. You know. So, right. So notebook and kernel, right? One application you open up is called notebook. This little bracket here is kernel, and notice it keeps nesting and nesting and nesting. You can have many layers. So you can have a function, you can have headline and so forth, right? Anyway, here, these are like plain text. This is enter using this. Remember, plus, I can do plain text. Okay, so now you do two more. If I do plain text, A plus B, shift enter, that's nothing because it actually thinks it's a text. This is used for annotation. Okay, so two things now you know, right? You know how to enter plain text. There's other style of text. This is kind of like format. Don't worry about it. This is the functional. Now these three will be very fancy, but we'll come to that in the second half of today. Okay, fine. Now, notice whenever I give it over to you, whatever result, it's going to print back echo. Like I got you 1 plus 1, give you 2. If I don't want to get it, for example, I can just silence it. Use semicolon. So semicolon is just like a silence. And it's also used to separate line. So I can do something like A plus B. Okay, and then B plus C. What it's going to do is going to perform A plus B, but not give you the result. Not give you the result, but then it's going to give you B plus C as a result. That's all. Okay, so in a typical programming, if you have more than one line, it will be separated with semicolon. By the way, it's not space sensitive. For those of you who come from Python background, you have to do like 2 space, 3 space. This is automatic. There's no spacing. Now, so if I did this, okay, 1 + 1 = 2. I can refer. Now, I don't use this very often. I can use percentage sign to say, give me what was given. So it's just going to echo the last, right? And this is kind of like shortcut that people came with, and it's not that useful. I don't use it all the time. But certainly, if I want to go to line 12, I can do this. Okay. Just to show you that now, this percentage sign is a function. What do you supply it with? The input. The input is the line number. So the function is, go get my car key. This thing is, go get whatever appear in line 12. Okay, so this is like, fetch me a key. Okay. Oh, sorry. Because they want a line, there's no bracket. Yeah, just a line reference. So this is not very useful. I don't use it at all. I rarely do that. It's like a good program shouldn't refer to things by line. So I tend not to do it, but some people use it occasionally. So I just want to give it to you. Now let's go to here. Okay, so this is all, yeah, you can do this yourself. I'm not kidding, right? X is equal to 1, X is equal to 1, 2, 3. So you can replace, basically overwrite. Yeah, X is equal to X minus 3. So in this case, X is equal to 1. In this case, X is equal to 123. In this case, you take 123, put it down, put minus 3. So now you get 120, right? Now, so these are kind of like assignment and recall. These are basic things. This is using things as a calculator, but never think of it as a calculator. Think of it as a shorthand for function. But that function happens to call add, subtract, multiply. Yeah. Right. So, another thing I should tell you right now. I don't know where I put it. So if A is equal to 1, this is an assignment. Okay. This is to say set A equal to 1. That's what the function is. But if I want to, the other function, I say, is A equal to 1? I want to do this. Okay. The notation for it is to make equal. I think this is with like Excel, if I'm not mistaken. I think Excel does this as well. Okay. Why does it not give me any answer? Why does it not give me any answer? Because it doesn't know what A is. Okay, it's saying this is, you ask me this, I'll give you the question back because I don't know the answer. But if I ask you something like this, is 120 equal to 5 factorial? What's a factorial? True. Again, this is also a shorthand. In mathematics, that is a function. Here it's considered a shorthand for a factorial function, right? 5 times 4 times 3 times 2 times 1. By the way, this is really fun. If you have a huge number, yeah, like 100, okay, factorial, you're gonna get a big number. You're gonna get a huge number, right? So 1,000 times 999, so it's a big number, but it's an analytical. Try that in ChatGPT. You'd be surprised what you get. You would expect it to either be wrong or be right. But ChatGPT is very clever because it can't do this, but because ChatGPT has read the internet, right? The internet says that there's an approximation, it's an equivalent formula for calculating factorial. It's called gamma function. So ChatGPT calls it gamma function. I was quite amazed. I was really impressed. Anyway, but it can't give you this. ChatGPT cannot give you this because this is a precise computation. How would you do this in ChatGPT? Let's say you don't have Mathematica. What you would do is you would pay for ChatGPT Plus, and maybe you have to sign up to connect ChatGPT with Wolfram Alpha. I'm going to show you that ChatGPT has a plugin, right? And then you can ask ChatGPT and say, go to Wolfram Alpha or calculate this analytically. Give me the right number. Not give me what you think is approximation. Let me show you something funny. You know you can't do factorial for a non-integer, right? Because this is actually a gamma function. Okay? Yeah, I'll tell you that. Okay, this is just a side note. So get used to the idea that, okay, so use this first as a calculator, right? Calculator, blah, 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 fine. The difference between calculator and a recipe, in a way, it's like how many shots you do it, right? If you crack an egg, that's one shot. But that doesn't get you anything. It's so simple. But if you crack an egg, take an egg, stir it, take the stirred egg, put in the, the whole sequence of function becomes a recipe, becomes an algorithm. Okay? So even though, yeah, I can do one thing at a time, normally when you write, you would write function as a sequence of the simpler, right? So I can say my function is to take add, and then take subtract, and then take multiply. Or I can write another function, my second function takes add, and then take my first function that I defined just right now, right? That would be equivalent to saying I mix egg, fry it, put it on the side, I fry rice, and I put the rice in the egg, and I wrap it, and I make a omelet wrap, fry rice, right? That sort of thing, okay? So you can define your function, then use it yourself in other function that you define. Okay, now, this is the first useful thing about computer is that it doesn't do things for tiny things. If you can do some computation on an object, you can do computation on 1,000 objects. Okay? How do you make 1,000 objects? You can list them. So this is the first instance where now it's not like just a calculator. It's a data processor. Because data is not just one line, right? Yeah. So think of it as processing, I don't know, omelet, but 1,000 omelets in a factory now. Yeah. So the most fundamental object here is called a list. Yeah. So list, again, how do I create it? I use the word list. List ABC. Shift enter. That's it. So I would actually do this. This is my shorthand. This is what you have to memorize. It's a curly bracket. It's not a round bracket. A, B, C. Okay. Now, what's nice about this, as opposed to a more rigid language, is that you can have a list of things that are not the same. So I can list anything. And this is where it's very modern in that you have to move to what's called a big data. You have to work in a variety of things. So I can't just list numbers or list characters, but I can list number, then character, then picture, then function, then this, and I can list anything. Okay? So it's just a way of listing things. So for example, I can say 12 blue birds. Shift enter. See that? What do you get? The computer understands that Z or that, right, is now assigned to three things. The first thing is number 12. The second thing is the color blue. The third thing is the word boats, right? Okay. So now I make the assignment. Now, if I type in Z, right, what do I get? Get this. What if I want the first one? Now, this is where you get what's called double bracket. So you have to memorize three things now. Square bracket for function, curly bracket for list, and then double bracket to specify element. Okay, so this will be like in Excel, you specify by column and row, right? In this case, you don't have A, B, C, D, you use number. So what's the first thing? The first thing is 12. So double bracket. Okay, and you notice that to make it look nice, it tends to make this kind of like a shorten, so it look nicer. In the older version, doesn't do that. So you want to get let's say I want the color. So Z2 is right. Okay. Now let's say what if I did this? -1. -1 is the same kind of index, but going from the end. A word of caution, those of you who came from Python world, you're familiar with starting with 0. Okay, that's another thing you have to memorize. Mathematica start with 1, not 0. Okay, so -1 means the last one from behind. Okay, so you can do that. And so this is it. Again, this is boring mechanic. Once you memorize it, you don't have to memorize anymore. This is like ... So from the beginning to the second, I use semicolon twice. Okay, so that would be from the beginning is 1, right? To 2, so the first 2. What if I want to start 2 and go to the end? That's this, right? Okay, anybody has a problem? No, right? Okay, simple as that. Okay, so now these are the baseline mechanic, the simplest thing that we have to, get used to. Other than the rest of it is now more logical, more interesting. So this is the boring stuff. So you just have to bear with it. Okay, it's like learning A, B, C, D, E, F, G before you know how to spell. Okay, so that's it. That's it. You have to be able to play with things that are. Computers don't deal with just one thing. That's no point. There's no point of having a computer do things. You just apply a computer to 1,000 things. How do you say 1,000 things? You name the list. How do you name the list? Well, you use a curly bracket. How do you access individual element of the list? You use the number in the order of appearance. You can go forward, you go backward. You can say everything from the beginning to end. So if I have something like this. Now, it's more interesting. What about this? Anybody guess what this is? This line. I have nested bracket. Oops. I have to move this thing. Hold on. Notice it's nested, right? It's not one bracket, but it's a bracket of things which themselves are bracket. Now, notice this. It's a list of how many things? You can say, yeah, you have to say it's a list of 2 things. This is a list of 2 things. This is thing number 1. This is thing number 2. But the thing number 1 is a list of 3 things. Yeah. Right? Does that make sense? Okay. Now, actually, it doesn't have to have the same number. So I can have like 5 things over here. But for now, let's keep them the same dimension. I'll tell you why it is, because that's where matrix algebra comes in. Okay. So technically, again, you can store anything. You can put an elephant here. You can put orange there. That's fine. But right now, I'm just going to say it's a list of 2 things, each of which is a list of 3 things. A what, sorry?
Is it like an array?
Exactly. It is an array. It is an array. Okay. So it is an array of. Now, how should you think about this? You should think of it as this. It should look like this. Okay. The first thing, the second thing, and the first thing has 3 things. So in this case, think about it. How would I get to the blue? How would I get to the color blue? Anybody? Well, you have to go from the outside in, right? Go. No, because this is a blue. I want this guy. I don't want this first line. I want second line. So if I did this, right? How do I get the blue? I just say RGB. Oops, sorry. RGB. Okay. Double bracket. Oops. Now let's try a few things. Okay. Let's try 2. If I give it 2, it's going to give you the second object. Second object. That's not what I want. I want the third object from the second object. Oops. Okay. So it's a list of 2 things, each of which has 3 things. So if I want the second thing, I put in 2. I want the third thing from inside the second thing, that's 2, 3. Okay. Now, this is 2-dimensional, right? 2-dimensional. What if I want to make 3-dimensional? I can certainly do this, right? It's a list of 2 things, each of which is a 3 thing, each of which is a list of 8 things. Okay, let me ask you, what is the most common 3-axis thing that you work with? Your computer screen. Because your screen here is a list of pixels. So that the first row is thing, the second row is the second thing, third row is a third thing, all the way down to the bottom. That's the row of pixels. Each row is a list of individual pixels. Each pixel is a list of red, green, and blue. Okay, so whereas this is dimension what? 2 by 3, right? 2 by 3. What is your screen? Your screen is say 600 by 900 by 3. Right? Your screen has 600 times 900 pixels. Each pixel has 3 numbers. So this thing is a 3-dimensional array. Sometimes it's called tensor. Tensor is a word we take from physics. Okay? Actually, tensor means more than this, but in data science, something like this they call tensor. That's why in machine learning library, there's a TensorFlow library because it works with image processing a lot. And image processing can be thought of as rows of pixels of 3 colors, right? 600 row, 900 pixel each, 3 colors, red, green, blue. Okay, and this thing gets processed. That's why it flows, called TensorFlow. Okay, but tensor is actually a word from well, you wouldn't use it in physics for general relativity. Okay, good. So that's it, right? So now you know how to make 2-dimensional array, and then 3-dimensional array. You can make 8-dimensional array, but 3 is already. Yeah. So list. This is a very so I'll give it to you again. Highlight. Somewhere. Yeah. It's manipulation again. So this is it. And once you have a list, you can join them, you can append. These are all nitty-gritty details. Now I'm going to go over the mechanics, so I'm going to skip this. You guys want a 5-minute break? Okay, let's have a 5-minute break and we'll come back. Okay, so welcome back to the second half. Yeah, in the first half, the only thing you have to that's new, basically that you have to memorize, I guess, that's a new way of working is when you tell Mathematica something, you have to shift enter to say, okay, over here. And the curly bracket, the double bracket, equality sign, double equality sign. Okay. เดี๋ยวคุยที่หลังเวลาตอนนี้มีค่า Okay, so actually they're not there's some function that cannot take argument. Not that it doesn't have a default argument, it cannot take argument. Why? Because it's very definite. There's no if, ands, or buts about it. For example, if I want to know what time it is right now, okay, right now, and if there's a function that says what happens in Copenhagen or something, that's fine. But right now, in this computer time, there's nothing. Okay, so you just write now. So that I call this a prompt. Okay, it's like a prompt because you don't really need to add anything. Same like today or tomorrow or something like that, right? Okay. Now notice that this doesn't give you a text output. It gives you some fancy looking thing. Okay. This is what's called a time object or a date object. Okay. So you get used to it. So you don't just have numbers. You can have date object. You can have graph object, and that's the power. Now, this is not a big data class, but let me just give you one word about big data. You know, big data is defined by 3V, right? 1V is called volume. It's big because it's got volume. 1V is called velocity because it comes really fast, and sometimes you have to respond really fast. But the V that we are talking about here, and in fact, the V I'm going to emphasize in my big data analytics is variety. Okay, so you don't just have data in terms of number. Now this is actually a number. This is a number. But here, because it's wrapped as what's called a date object, you can do a lot more to it. Okay? And this is something that unfortunately you don't get taught in high school because it's considered abstract algebra. Think of abstract algebra like this. Okay? You can add, you can multiply, you can divide. But certain numbers, you can do more. Certain numbers, you cannot divide, for example. Okay? So things like a human being cannot be divided by 2. Okay? Likewise, not all numbers have the same operable functions. So in this case, because it's a number that represents a date, meaning July 5th, 2022 or 23, you can do something to it, like look up event associated with this date, or maybe point to a calendar. Okay, so even though it is a number, you can assign it a number, right? You can say that 0000 of year 0 as 0, and then the January of that day is 30 or whatever. You can assign a number, but there's more to it. There's more meaning to it. So that's why you don't see something like 2023. You see this kind of nice wrapping. Anyway, now here is an example of a function that has 0. It is a function, it takes an argument, but it takes no argument. It's a little bit different than here, okay? What this usually means is that you can actually put something in here, but you don't need to. So if I did this, what it does is it just say, where's my directory? The directory of this notebook. I saved it somewhere. I want to know where it is. Yeah. Or let's see what else, what other example I have. Okay. So these are like function that has no argument. No argument. Okay. Now you can imagine. Okay. Now I haven't told you how to define your own function yet. Okay. But let's say I can make something like fried rice function. And if I put something like this, like fried rice with eggs and beef, okay? I'm specifying that it is a fried rice with eggs and beef. But again, the concept of a high-level function is, if I don't specify something, there's always a default. So if I say something like this, it would also know how to make fried rice. It would just make the most generic version of it. Okay, so this is where it's slightly different from the concept of function in mathematics. In mathematics, if a function takes 2 arguments, it always takes 2 arguments. Okay, in this case, the function can take 2 arguments. Sometimes you can take this 1 argument, sometimes no argument. It's not because the function is incomplete. It's the fact that it knows how to fill in the blanks for you. Okay, it's kind of convenient. This is called default argument. Okay, and some function would have a specific list. The first argument refers to the dimension. The second argument refers to the color. If you don't specify the color, I'm just going to give it blank. Okay, some function can take as many arguments as you like. For example, list. You can put in 5 arguments, it's a list of 5 things. You can put 10 arguments, it's a list of 10 things. Okay, so function in this case is more general than concept of function. Okay, you remember for those of you who've been to a real math class, you say function going from R2 to R1, right? It's always 2. That function always takes 2 arguments. If you give it 1, it complains, it dies. If you give it 5, it dies. In this case, if the function expects 5, okay, and it's created such that the last 2 has default. Yeah, so just look at my hand, I'm just going to say, this is a function, it expects 1, 2, 3, 4, 5. But the way it is defined, the last 2 is an optional because it has default. What this means is that you can't give this function with 8 arguments. You can't give this function with 1 argument. You can only call this function with 5, 4, or 3. Right? Because it's expecting 3. But if you it's expecting 5, but the last 2 as default setting. Yeah. And you're familiar with that. And all kind of application has default setting. So that's what it means. Okay. So that's how you call a function. And this page. Right. Now let me give you an example. Okay. These are examples that are used a lot. For example, exp. This is a built-in function. This is exponential function. Okay. So exponential function. Yes. Now let me show you something about Mathematica. It's built for people who are precise. When I say 12, and I say 12.0, I say the 2 different things. When I say 12, implicitly, it's a counting number. But if I say 12.0, it's a measurement. So if I did this, and look, yeah, watch carefully, 12 dot, right? 12 dot. I get this number. Okay? Because it says I'm giving it 12.0. Exponential 12.0 is 1, 2, 3, 4, 5, whatever. But if I did this, this is more precise. It's giving you e to the power 12. Okay, so let me show you again. Once again, let me try. It's not a trick. It's a feature. It's actually a design feature that people appreciate more. So this gives me numerical value. This one is more precise. It's like 1/3. Okay, have you been taught that in grade school? Do not make approximation until at the last possible moment. So you don't see 1/3 and you write 0.33 because that would be erroneous, right? You write 1/3 until the end. Likewise, if I want this to be, I get this result, right? I want to put this into a function that say, give me numerical value. I really want numerical value, okay? I put in another function. That function is called n. It's used so often that, skip one function. So right away, you see that? This is how function gets the result and then use it as an input. So now if I did this, it gets a number. Okay, but by default, if I didn't say so, it's more precise. Same thing. If I write 1/3, it's not going to give you 1.33. But if I force it, okay, I want numerical value, okay? Fine. Not very happy about it, but yeah, fine. I'll give you 3. Okay, so you understand the concept. Now, another useful function is the length. And this just obviously means if you have 3 things, the length is 3, right? Now, length only works for list of things, right? But what if you want a list of lists, like what we saw right now? One of you just said it's an array, right? So RGB is an array. So what's the dimension? 2 by 3. See that? So if I have a screen object that is 600 row, 900 pixel, 3 color value, and I put this object, store it as my screen, and I put dimensions of this screen, what am I going to get? I'm going to get curly bracket, 600, comma, 900, comma, 3. Yeah. Now I do this a lot, and what I do is I have a lot of projects, both consulting or teaching or whatever. I tend to put everything in a little application. For this job, I have a folder. So a lot of time what I do is wherever I save it, I will just set that notebook to the directory. Okay. So this is a question. Okay. Where is the directory? Where is this file? Where is this thing that I'm working from? Set directory means from now on, input, output, I'm going to get from this. Obviously, I can, in a big project, I can say set directory, input somewhere else, whatever. But in my code, I tend to do this a lot because I have a project that wraps everything all together. Yeah. So notebook directory just tell me where it is, where this file that I saved, this notebook file save is, right? And set directory just means from now on, I'm going to work here. Yeah. If I'm going to read something, I'm going to read from here. If I'm going to look. So let's specify, I do this. So all this, okay, row, column. Now, grid, this is something that's kind of nice. Grid is like an organization, and I tend to do this a lot. You may not need to. What it does is that instead of having a list of lists, it just makes it into a grid. And I put frame all so that, it has a frame. Looks nice. Just formatting. Okay, now here's a fun thing. So now, okay, this is looking ahead a bit. Looking ahead a bit. This here, well, how many of you did calculus already? Okay, you will know about Pascal triangle, right? Hopefully. Okay, well, this is basically a Pascal triangle, right? Now, the only thing I'm doing here is just to say that I create a Pascal triangle and I put it in a grid so that it looks nice, and I put frame for the first 2 of them. This is just fancy way of looking at it. Doesn't matter. Okay, so it's not that interesting. Okay, this is factorial. Okay, this is it. This is what I was telling you earlier, that factorial is a gamma function, right? Factorial of x is the same thing as gamma function of 1 plus x. Now, Let me go to this empty space. So if I say something like f1 of x, right? And let's say, I'm just going to write and ask you, what do you think this means? G of A and B and H. Okay, what do you think this means? This looks very complicated, right? But that's like cooking recipe, right? Prepare the egg, set aside, make rice, put the rice in the egg, and then wrap it and so forth. So how do you read this? I can make it any complex version I like, but all you have to say is C is work from outside in. Okay. By the way, if you go to a fancy restaurant, that's the rule of utensil. You get 5 forks, 7 knives, or something. It's work from outside in. Same rule. This is a function h of 1, 2, 3 argument. The first argument is just a number. So you get it from the fridge. Second thing is a function of a variable. So maybe you have to crack the egg first. But this is a function of 1 variable. The third thing is a function of 2 variables. Right? So ultimately, this thing is a function of how many variables? It's actually a function of 4 variables. You count them all, right? So this is, to make this dish, you need 4 ingredients. But the way it's done, you take one ingredient, you take another ingredient, do some pre-processing, maybe put in a moulinette or something, okay? Then you take these 2 ingredients, egg and fish sauce, and stir them, okay? Work in, work in, work in. Yeah. Notice how compact this is. If I were to write this in a cooking recipe, I would have to do exactly what I just told you, right? Do this thing to A and B, put it aside. Do this thing to X, put it aside. Bring 1, add, I'll put all these 3 things and do something to it. But in a function language, it's very compact. But it looks complicated, and that's why sometimes people don't like mathematics, because it looks too compact, right? It looks, but to be honest, think of it as economical way, right? Economical way. If you want to sort of like write like a love letter in in a little piece of paper and put it in a pigeon or whatever, you have to write compact information. So imagine writing this in English. Right? This is much easier, right? This is much easier than English. Okay. Now, let me show you something else. If I did this, f of, say, x, and then g of f, okay, and h. Yeah. Now, mathematically, this is correct. I can write this. What it means is that overall, I just need 1 variable. I do an f to it. I get the result. I do g to it. I get the result. I do h to it. I get the result. Now, notice that there's a little bit of helper, because you have to do count, right? You have 3 brackets in the beginning, so you have to have at the end. So if you did this, it's going to kind of try to highlight and say, oh, you haven't got enough, right? But anyway, occasionally it gets very tedious. Occasionally very tedious. So there are 2 shorthand that is introduced. Instead of function, open bracket, close bracket, if the function is applied to only 1 variable, okay, for 1 variable, you can do this, f at x. Okay, it's a shorthand. So you can say apply f to x. This is called pre-applied notation. So that way you don't have to write another bracket at the end. Okay, now, if I want to write this, you can do take f, apply to x, take g, apply to f, oops, apply to x, and then take h, and then apply to that. You can see why this is very compact. Okay, a lot of time you will see this in a community, they would write something as a shorthand. Okay. Now, if I write this, I look more like a pro. If I write this, I look more like a baby. Now, there's another thing that's called post-apply. Think of it this way. You can think of take an X. Hey, sure, bring it to me. Okay. This is called pipe notation. Apply F. It's called pipe notation. Once you're done with that, you take, and then you apply G to it, and then apply H to it. All this equivalent, completely equivalent. So this thing is equal to that thing. Again, today. Now, sometimes you have to use round bracket to help, because what happened is that it does this first and then it does this. So I have to wrap everything together. Okay. This is what's called precedent. You know the internet meme where you say something like 2 divided by 1 multiplied by 7 and genius cannot solve this. Well, actually, anybody can solve it as long as you know the precedent. So you have to do this. So my question is, if I did this, f of x and apply a, what's that equal to? That's this. So this here, f applied first, takes the precedent. In other words, it's closer. It gets a pattern. Yeah, and then it does this. So that's why if I didn't have this bracket, it's going to wrap all this as one thing. So this, let me just keep this in line. So as a reminder. So anytime I send you something like this in the line group, you can just copy paste and try it. Okay. So it's just a reminder. Okay. So now. Okay. So all this. Now, obviously, everybody knows this, right? Log of exponential, same thing, exponential of log. So you can do all this. This is very simple. Okay. Now we're starting to get to where we think of things as object. Think of lists as vector. Raise your hand if you have not heard of linear algebra at all in high school. It's okay. Okay. Because some people went to right? Track and they don't have. You have done linear algebra, all of you. Good. Okay. Well, what's a linear algebra? Well, linear algebra is just linear algebra applied to variable, except you are so lazy. You don't want to write 5 equations in 5 unknown, right? You don't want to write 5 equations in 5 unknown. So you make coefficient matrix and call it A. You list x1, x2, x3, x4, x5, and you call it vector x, right? And then you say y1, y2, y3, y4, y5, and call it vector y. And now you write y is equal to ax. Then you're done. Okay, so matrix algebra was born out of laziness, if you think about it. The point is that when you did this, you can specify what you do as y is equal to a of x, and that a can be 1,000 numbers, 1,000,000 numbers. And that's the power of data science, because you did this mathematically first. You solve all the relationship y is equal to a of x. Okay? So basically, if you think about it, this job, this data science, by the way, when I was your age, they didn't call it data science, we were just called quant analyst. Okay, what's a data scientist? A data scientist try to predict y from x. That's they do many things. They do more things than that. But one of the major job, one of like 80% of the job. Okay, if you apply for a job as a data scientist, you spend 80%, 70% of your time doing y as a function of x. In this case, x happened to be 5 number. Y could be just 1 number. Your job is to come up with the a that when multiplied to x gives you the best prediction for y. Yeah, so that's mathematician's job. How do you do it? You do it by looking at historical x, historical y, and comes up with a that worked well in the past data set. That's what makes you a data scientist, right? Because if I just write y equals a of x, I'm just a mathematician. But if I calibrate a by testing or checking, by looking, tuning the a so that it works well with the data record of the past x and y, then I'm a data scientist. Yeah, so think of that. That's it, right? So the most fundamental thing you did in grade school, right? Adding, multiplying, subtracting, and then equation. What's equation? That's just saying that whatever you've done on the right-hand side, you store it on the left-hand side. Or whatever you've done on the right-hand side and whatever you do on the left-hand side is the same thing. So equation serves 2 purposes. Say that the right-hand side, the left-hand side is the same thing. Or in this case, you are assigning whatever is to the right-hand side, the complicated bunch on the right-hand side, y is equal to all of that. Okay, so equation is a naming. It's a naming job. Okay, whatever complicated things you do on the right-hand side, I'm just going to call it y. Okay, so that job is what data scientist does because you're not trying to name y, you're trying to predict y from whatever complicated things happen on the right-hand side. But you came up with it using mathematics because y is equal to a of x. Mathematics is the matrix algebra. You use data because you're not just dreaming up the matrix. You use this coefficient based on what you saw in the data. So it's empirical. So it's mathematics plus data become data scientist. And that's 80% of data scientist's job. Trust me. Data scientist's job gets increasingly boring. It's a lot of times it's really boring. But now it gets more exciting. Anyway, so the whole point is that let's start thinking of this thing as a matrix. Now, how would I do this? Let me do this. Where's the empty place? Okay. Do this. Bracket. Okay. Let me do this first. Let me do this first. Okay. Right. This is a simple thing, right? It's a list of 2 things. Each of which is 2 things. It's a list of 2 things, right? How many rows? How many columns? 2 rows. It should look like this, basically. Think of it this way, right? Right? A, B, C, D. 4 things, but arranged in this array. Now, obviously, okay, obviously this is a 2 by 2 matrix, right? And that's how Mathematica, how you name this thing. This is my matrix. So A is equal to this. Okay, right? But it doesn't look nice. So sometimes to format as a matrix. Now this is where things would look more like mathematics. Matrix format. Okay, let's apply matrix format to A. See? Right? But this is not how you program matrix. A matrix is a list of lists. Okay, you do calculation here, you do calculation here. So for example, let's say you want to multiply this by x1, x and y. What do you do? What's a matrix multiplication? It's like a dot product, right? Right? Now, of course, this is correct, but it doesn't look nice. So at the end of all this, you can say matrix form. Okay, but don't mess it up in between. So do everything in list. So what I'm trying to say is that matrix algebra, remember last on Monday, the mathematics that will get you throughout life is matrix algebra, linear algebra. In Mathematica, linear algebra is written, the vector and the matrix and the tensor, everything uses curly bracket. So curly bracket is universal, but it doesn't look nice. So once you've done everything and you want to print a result or something, sometimes you can use what's called matrix form. Okay, form means format. There's also this thing called table format. A table format just kind of line them up. It doesn't look as nice. A, B, C, D. Okay, and this is just formatting. Okay, so this is not this. So it's like a presentation. But notice, this thing here is exactly what you would get if you get A, B, C, D, and then X and Y, right? Because 2 by 2 multiplied by 2 by 1 is equal to 2 by 1, right? You know that, right? Okay. Now, if you have a problem with linear algebra, please, don't be shy. You know why you shouldn't be shy if you don't know how linear algebra? Honest to God, I'm not lying. I'm not trying to be nice. I did not learn linear algebra in high school. Honest to God. The first time I did linear algebra was in second year of college. Because back then, the concept of working with a lot of numbers together is something that's kind of specialized for database or something like that. So the most general concept that we learned in high school was calculus. So I would learn calculus, calculus, advanced placement calculus. I would learn physics, advanced placement, but I never learned linear algebra in high school. And in fact, the first year of college, I also didn't use linear algebra. I learned linear algebra in the second year. Now they adjust the curriculum because linear algebra becomes so ubiquitous, again, from graphics and all that, that you can actually see some high school would teach linear algebra, but not calculus. Okay? So, to me, matrix algebra for me was like a fancy topic in college. So no shame if you haven't done a lot of matrix algebra. Okay? So all this, again, the dot is a shorthand for the function called dot. Okay? So dot. Now, this is where it gets a little bit cool. You know what this function is? Yeah. What do you think this is? This is a mathematical function, but it's written in a programming function, power, with 2 arguments, x and 3. What it means is that it raised x to the power 3. So this is the same thing as x to the power 3. So let me do that again. Let me come over here to a blank page. Yeah. And shift enter, x to the power 3. Okay? So this is actually shorthand for this, but actually this is the more fundamental. Okay? Now, of course, now that you can raise x to the power 3, you don't want to write this, right? It's very cumbersome. So I can literally write like this. Now, how would you do it? You can memorize, but you don't have to. But here, go to here. This is called palette. Can you see this? Palette, basic math. What it does is it allows you to do all this kind of notation, like to raise power and all that. So this is like template, like in Word. This is kind of like a Word. Yeah, it's kind of later generation of Mathematica when people are used to like using Word or something. But because I use it so often, I might as well memorize the keystroke. So it's X, Control, hat, and I put in. Yeah. You know, you have a hat, right? I'm not sure if in MacBook it's the same, but I think it's the same. X, Control, hat, and it would raise it up. Now, subscript, I can do subscript as well, by the way. X, Control minus, and it goes down. Okay. Now the difference is that this is just an index. Okay. Index. Whereas this is actually to the power. So you can write something like 1 plus x to the power 3. Right? Now, if you want to expand it, see that? Okay. Yeah, see that? So what does this do? It raises 1 plus 3 to the 1 plus x to the power 3 and then expand it. Now, this is where it doesn't look nice because in Mathematica, it lists things from low order up. Okay, but in Mathematics, what's the tradition form? What's the traditional way of writing things? You write x3 first, right? So I can do something like a traditional form. Yeah, then it looks nice. Actually, not only does it have the right order, it makes x into this kind of nice script. Again, this is all formatted. Every time it's formatted. Okay, right. So now, this is the simplest thing that your little brother, your little sister can do it. What's the derivative of x squared? 2x, right? You can't do this in Python. You can't do this in any programming language because it's not an analytical engine. It doesn't understand derivative. Okay, but Mathematica, you use derivative so much, they don't even use the word derivative, they just write d. So d of x, shift, hat, 7. Yeah. Oops. Sorry. With respect to x. Okay. So this is basically derivative of x7 with respect to x. Now, you can write a nicer way using this kind of form template, like here, I think. Yeah, there it is. So, okay. So let me copy this, but it's not going to show very well, is it? So with derivative with respect to x of x to the 7. See? Why do I use the notation partial? Because partial is more general, right? And you don't want to use these, so it's considered partial. Partial for one variable function is the same thing as a straightforward derivative. I've actually used this in real life. I'll tell you why. Because I used to run data analytics or quant analytics at Siam Commercial Bank. There's in financial market trading, there's this thing called options. I don't know if you know what option is. It's called financial derivative in the sense that you have like a stock price or FX, and then you have instrument whose price is a functional dependent on that. It's used for risk management. Anyway, the model to describe that is described in terms of partial differential equation or differential equation. In market, you have to work out what's called sensitivity. Okay. In other words, if the market variable moves this much, what happened to the value of my investment? Okay. So this is called partial derivative. With respect to this parameter, with respect to time, with respect to interest rate, with respect to this and that, the model is so complicated, I couldn't do the derivative myself. If I did, even if I could, I'd probably make a lot of mistakes. So I actually use Mathematica professionally because I want to get the derivative form that is foolproof. Okay, so I'm not using this because I don't know how to take the derivative of x to the power 7. Okay, and you shouldn't do it because you don't know how to take the derivative of x to the power 7. But the programming language is there so that, again, you can work on things that are a lot more complicated. Okay, and you can't do this with Python. You can't even do it with x squared. So this is one of those things where you definitely need. Now, when would this matter? This would matter in certain relationship, like you're doing a kind of pricing model. So a lot of time it's expressed as a calculus, so you can't get away with it. You can't get away with it. But that's not to say that I don't want you to learn calculus. Again, learning calculus has two purposes. One, because you're going to apply calculus. Two, because as Neil deGrasse Tyson said in the video that I sent you, the process of learning calculus teaches you the problem-solving skill that will be valuable. But when you do it professionally, you don't want to make arithmetic or calculus chain rule and then you get the wrong answer. So you might want to do it yourself manually, but eventually you use Mathematica to check the result. And I do that just to be safe. Yeah. Now, same thing. You can integrate, right? What's integration of x squared? X cubed over 3, right? Right? You can do analytical integration. You can do a lot more complicated than this, obviously. Now, if you are a little bit fancy, you don't want to use the word integrate, you can go to palette and go to notation and use this thing. Okay. So what were we trying to do? Say 3x to the power 9, okay, with respect to x. Okay. It's the same thing as integrate x 3x to the power 8. Okay. So, okay, let's pause a minute. What's the point of all this? Okay, we can't get much more covered in this. So, what's the point of all this? What's the point of all this? Point of all this is that a lot of things that you will run into will be expressed in what's called white paper. Okay, academics, they write journals. But if I'm writing a software to sell to the investment community, the way to convince them is to actually write what's called white paper. It describes the methodology of my algorithm. Now, as a user or developer, you want to know that the mathematics works or how does it work. It's shown as a formula. You know calculus, but maybe you've forgotten calculus, or you don't want to really do everything from scratch. So what you can do is you can take the formula that is written on the website's white paper, put it into Mathematica, and then you can do all kinds of stuff. Okay, so a lot of time, software vendor will tell you the function, but they'll try to not be elaborate about it because they don't want you to copy their idea. But if you can actually take the formula, put it in Mathematica, you can plot three-dimensional plot, change a variable, check the condition. You can do all kinds of things. You can get insight into how things work. Okay? That's like saying that you bought a car and the car has a manual, and when you open up the manual, it just got a picture of an engine, right? But there's no way for you to analyze or something like that. This is sort of like allows you to actually get behind the scenes. Now, not all of you will have this capability or this kind of skill, but it's there. Okay, so you can use Mathematica as a way to prototype your idea, or you can use the Mathematica to take somebody's algorithmic idea and then play with it so you understand how it works, so that maybe you can improve on it, not steal it. And that is not the whole point. It's not here for you to steal somebody's formula, but you want to understand it. Like you invest in your own money. You want to know that this algorithm works. Okay, you can do this yourself with high power mathematics. So all this calculus will be, because it's done, with a software, it's probably more reliable than if you did it by hand. Okay, so I'm not trying to say that you don't need to learn calculus. Yes, you need to learn calculus, but in practical life, when you try to bet your life or money or your life saving on it, you might as well have an analytical engine check your work. And this will do it. Okay? So now obviously, they don't give you this for high school, otherwise nobody would learn calculus, they just key everything in. Okay? That's not the point. Okay, so I hope you understand my point. This is not a shortcut, so you don't have to learn how calculus works or how relationship between variables work. But it sure helps for you to tease more insight out of it. Okay, and I'll show you what I say now may not make that much sense because you're not getting much insight from doing this. But once you get to visualization, which is maybe not Friday, but maybe Monday, you will actually see. You see what happened to x when you apply this function. You see what happened to this function when you change your parameter. Okay, that's called interactive mathematics. That's basically the title of this course. So we have got to interactive part yet, right? Now it's just mechanics, like I said, it's a boring class today. So Friday, we'll move a little bit, okay? And I'll try to finish the mechanics by Friday and start to go into the mathematics and hopefully by the end of the 2-3 weeks together, even statistics you will have covered. Okay? So anyway, so today we kind of out of time, and I think you've been very good. And I'll see you. By the way, I was trying to move the class in the afternoon, but for some reason they already booked this. So Friday is morning, 10 o'clock. Okay? Morning, 10 o'clock. And it's going to be 10 o'clock from there on. Okay, good luck, have fun, and if you have problems, see you at Stanford. I'll see you on Friday. Yeah, so don't go yet. Okay, in the next 5 minutes, turn whatever you've got into my course view. Okay, and so what we do is about 15 minutes. Stanford, let's make it like 15 minutes after class. It's